file system implementation based on the file structure that we have discussed last week. In the last class, we have seen what is a file system and several different kinds of the file system. Okay. Then the key part is how the file system organized a block to store the file. So basically most of the contemporary operating system, including some of the application programs such as the database system, they are using block-based approach to store such a data because we use the block as a basic unit of I/O. We can get the benefit of the not only just reducing the fragmentation, but also we can get the efficiency, speed up. So, for example, we can use such a block as a cache by storing such a read block into the memory. So, to manage such a block in your file system, the first approach is the contiguous allocation. So we can store the file, save the file in the contiguous available block. Okay. We can extend the idea of the contiguous allocation to the extended-based system because the benefit of the contiguous block allocation is simple. So as long as we have the enough size of the contiguous free block, it can store the file. However, even though sometimes we have the enough space, but if we do not have the contiguous block, we cannot store such a data. So to address such a problem, we can instead of managing the contiguous block, we can manage the extend the block. Extend means is the some number of contiguous block. For example, such as 5 or 8 or 10. So we can manage such a extend by extend. So instead of finding the one big chunk of the free block, we can allocate such a free extend to the file to store the data. Such an extend-based block allocation is currently used in most of the database system. Database system, when they create the file, table, they allocate the extend instead of the I/O, the block. But however, when they read the data, they do not return the entire extent. Instead, they return and say the read and write based on the block. Okay. So, example of such an extend-based system is the data file system, BFS. We will see the BFS one more time later, the base class. And another approach to allocate such a free block is using the linked. It's like the linked list that you learned in the algorithm class. So in the linked list, each data item has the link of the next item, and so on. So when you search the data using the linked list, you can start from the beginning, then the travel until you get the data. It's the same idea. So when we store the file data into the file system using the linked allocation, unlike the contiguous block, we don't have to find the big chunk of that can keep the entire file. Instead of such a big chunk of the block, instead we need to find any available block, free block, then store the data. If you need more block, and then find another one. Then in the first block, you can keep the address of the next block, just like what you can do in the linked list data structure. So, for example, if we have the 4-byte address format, so we can allocate the 4 byte of the block for the address of the next linked block, which means in capacity it will be slightly less than the contiguous block, because anyway this 4 byte of the block will be used for the pointer of the next block, so the capacity will be smaller. However, using the such a linked block, we can actually remove the such a external fragmentation that can be, for example, even though we have enough number of flip blocks, but using the contiguous, sometimes the extended based allocation cannot store the file that is called the external fragmentation. We can avoid such a external fragmentation. Also, we don't, because there is no external fragmentation, we don't have to worry about the compact. So compaction means if you have used Windows 95 or Windows ME, probably from time to time you did the disk defragmentation, that is a compaction. Okay. However, you need to manage such a free space, free block to allocate the file. Okay. Also, reliability can be the problem. What if we lose the link, one of the data block, lose the information about the next pointer, then at that time you may lose the rest of the data because you cannot find the next address. That is the problem of the reliability of the linked list. Okay, so basically the FAT5 system that has been used in the old Windows system, Windows FAT16, FAT32, are based on the file allocation table. Okay, then the last one that we discussed the last class is the index-based allocation. Index-based allocation, instead of keeping the address of the next block in the current block, we will have we will allocate the one block or a number of block to keep the entire address of the block used for to store the file. Okay, and this one is called the index table. So we need to manage the index table like this. In this file, to store the file name of the zip, we need to first allocate the block 19 for the indexing block. This block has all the address of the data block. Okay, the benefit of using such an index block is if you can do the random accessing. What about the linked list? You need to visit from the first block, no matter where your data is stored. You need to start from the beginning block and travel entire until you find the data. However, using the index, so you can find directly the block that has the data that user requested. It's good for the random accessing. Probably, as you can guess, you need to more space to keep the index table. Also, you need to have the address of how to store that. This is the one of the simple naive way to keep your indexing. Right? You can think about other indexing structure. What did you learn in your database course? So you have the single level index, multi-level index, tree structure, B3 index, B+3 index. You can use such a indexing structure to keep the index of your data block. Even some of the file system use the B+3 index. Okay, so exactly same problem. Okay, so to find the data block using such an index. Yes.
Indexing table, what should be installed in our project too?
If you want to use the index, the allocation, so you need to allocate one of your data block, okay, for index. Then store the information about information means the block address, block ID, or block number, or sometimes you can directly give the offset address of that, okay, of your file block. Okay, so for example, your file need the 3 block, like this one, this one, this one, and first you need to find the available block to keep the address of these 3 block and the source here. Then when you read the data, then first your directory structure should link what? This index block only. Then first you need to visit the index block, then find the location of your data. Okay? As you can guess, this one is good for big file system, right? You can manage a number of blocks. So in the index, so you can easily, quickly find such a block. However, if your portable file system, PFS, is quite small. The initial size is 10K. It's a small size of the file system. So I don't think it's a good idea. Even slower than the contiguous allocation or the linked allocation. Okay. So index allocation is good for the big file system. We will see how much big is that. Yes.
Question. We should implement that data block as a data structure, right?
Oh yes, block-based is a basic thing in your portable file system.
Okay.
So
The number of the data blockers should we decide here, right?
the number of block will be determined by file system size.
File system.
Yeah, because I already give
Yeah.
the block size, right?
Yeah.
Then is the initial size is 10K. Also, you need to think about what? Directory structure of your file system, other information. Then how much you allocate is up to you. So you need to design your file system, how many blocks you are going to create. That is called what? It's a formatting. So when you format your data, actually it's kind of the format, make the line, read line, virtually. It's a kind of a virtually read line and make the block, and whenever you have a data to store, then you use such a block. In real case, what is a formatting? Formatting means in your you first allocate the directory structure, okay? Then in your directory structure, you need to manage offset of your data block, okay? So that is the processing of the formatting. So in your project, when you open your file system, you need to do such a thing. Initially 10K, you need to create a file size 10K. Then you're inside the file, you need to design. In your program, you need to design how much you allocate for the directory, and the other will be used for the data, and the data area will be formatted by the block. So you will have the number of free block initially, then that information will be stored at your directory structure. Okay? Then you need to decide one of the allocation approach, contiguous and what else? The linked list or index, it doesn't matter. Okay? Yes.
In project 2, what's the maximum size of directory structure? Because
I didn't give any maximum size.
we can limit that.
Yes. But if you need the more space in your file structure, it can be added by the 10K, 10K, 10K. Then I give the naming rule of that file. It's a PFS.1, 2, 3, 4. Then in your operating system, you can easily recognize which one is the first file and file system, and the second one, third one, something like that. You need to also think about when you add the one more file system in case of full, okay, like add the PFS2.2 at the time. If you can, whether you need to decide in your directory structure whether you are going to manage how many, what is the maximum size of your file system. It depends on what? It depends on
how many blocks?
addressing, right? It's the addressing problem. So addressing how many bytes you use to address, okay, offset of the block. Then you can multiply by number of block. That will be the size of your directory structure. Okay. Also in addition, so you need to design first before you start. So when you add the PFS.2, okay, are you going to manage PFS.2 separately in their own data directory structure, or from the PFS.1 file structure will manage? You need to decide. Okay. So I suggest that for your easy implementation, this is a PFS.1 file. You have the directory structure and block in case it's the full, there's no available. Even though you have the available space, so if, for example, if you are using contiguous allocation, so you may not have the block size of 5. At that time, you need to create this one. Are you going to manage this block separately? You can only use the free space here, or you ignore all of that, and all blocks will be managed by the master head of file. Okay? Yes.
How many BFS that we have in implementation?
It depends on your directory structure, based on the addressing format. Okay? So I'm not going to specify. That's the reason. It can be 10, 12, but there might be maximum because of it. There might be a limitation of the directory structure. Then how many blocks can be managed by this one.
So which means if I have enough bits to represent the number of the PFS file, I can
Then
have
it can be.
anyone.
So for example, half of them will be directory structure. It can you may manage more blocks, right? But it doesn't have to be such a big. Okay, it can. So we discuss about the 5 control block FCB, and also you need to manage the free space. We will see how to manage the free space. It doesn't need the huge amount of space. Okay, and something like that. Yes. Okay. So what if so one block size is a 512 byte. Okay. For example, I'm going to use the 4 byte, the word addressing format. Then how many blocks can you keep in this one block? Divide by 4, 128 blocks. What if the file is bigger than 128 block size? You need to have another index, right? Another index. So managing index is complicated. Also takes time. At that time, you can have index of index. This index managed is index file, like the multi-level index in database. So when you search the specific block, first go to this one, whether this data block is located, and go to this index block. Finally, you can find the data block, something like that. At that time, the number of blocks that you can manage is much bigger, right? So if you need a bigger size, then you can have another level. So that is the multi-level index allocation. In case of the 2-level index, using the 4K block and 4 byte word size, the addressing, the pointer. At that time, we can have up to the maximum size of the maximum file size is up to 4 gigabyte. That is the reason in Unix system you can create up to 4 gigabyte in 32-bit addressing format. You can create the 4 gigabyte size of file. So this is the layout of such a multi-level index allocation. We have the index block of index block. This is the index block. So index table is the spread out a number of index block, and finally data block. It's the exactly same approach as the multi-level index in the database. Then we can combine such a direct allocation or the linked list, and also single level, multi-level, and something like that. So that is called the inode. Direct block is this you can directly the point, the data block. Okay, how many? 12. And single indirect means that we have the single level index block. So index allocation. And double indirect is we have the index block of index, like this one. Triple indirect, we have another level. Okay? Why we have such a different combine the scheme in one the block allocation? each one has pros and cons, right? For example, the direct block is fast, but there might be limitation for the size, file size. This one is big. You can make the big file, but however, you need to visit this one, this one, this one. Each node requires I/O. It takes longer time. So if the files are frequently used and the small size, you can actually manage by the direct block. Otherwise, you can manage it's a big block, it's not frequently accessed. You can manage such a the file using the triple or the double indexed allocation. This is called inode. So this one, using the 32-bit addressing format in the 4K byte, the inode can manage up to the 4 gigabyte. That is the reason the Unix system you can create up to the 4 gigabyte files. Okay. Regarding to the performance of such a different scheme, the continuous definitely good for the sequential searching, sequential accessing. On the other hand, the indexed allocation is good for random accessing because you can directly access the data block using the indexed block. What about the linked list? Linked list support only the sequential, but it's good for utilization because there is no external fragmentation. Okay. This is a performance test for the specific. Have you ever heard about the MIPS? MIPS? It's not very important for the computer science, but the computer engineering or the mechanical engineering, the electrical engineering. When you are designing processor or CPU, it's very important. What is a MIPS? It's the millions instruction per second, which means it's the barometer to evaluate the performance of your CPU. Which one is better? The 1.7 gigahertz or the 3.0 gigahertz CPU? Definitely 3.0 gigahertz. The CPU is better. What does it mean? How many cycles per second, right? In one cycle, it can process the set of instructions. At that time, we can count how many instructions are processed. So how many? So millions of. So for example, the Intel Core i7, which is one of the latest technology of the processor, it can process almost 160,000 millions of instructions per second. Okay. At that time, there is another unit that is IOPS, that is the IO per second. Okay. So we can actually increase the performance by using the different allocation scheme. Because the I/O itself is the most expensive one, if we can reduce and increase the performance such as IOPS, we can increase eventually the MIPS, the instruction per second. This slide is a benchmarking test of that. The next topic is then how we can manage such a free wheel. First, we need to find which one is free, which one is not. At that time, we can use such a it's called the bit vector or the bit map. It's a series of the bit. For example, in this case, to manage if we have the n, for example, 128 blocks in the file system. If we want to manage maximum 128 blocks, okay, at that time we need 128 bit string. The bit vector. Then each each one represents whether block is available, free or not. In case the free, we can assign the 1, flag value is 1, otherwise if that is used, that is you can set as a 0. For example, too many 128, so we can have how many bits? 128 bits. How many bytes? You can just need 16 bytes. 16 bytes is enough to manage the free list of your file system that has the 128 blocks. So you need to decide the maximum size of the block, then you can allocate this one. Then first 0 is occupied. First it can be set as the initially 1. Then once it is used, you can just simply change it to this one. Then what about the address of this? You don't have to actually manage address of this. You can actually multiply by block size plus initial offset. That's it. In case it's more than the maximum size of the one file system, then you can actually recursively calculate the address of that. You can modulo by the size of this one. So you don't have to manage the direct address. Okay? Just you can use the 128 bit to manage 128 byte, 128 blocks, then find the location. Then at that time we don't have to manage such a big directory structure. Instead, we can make it smaller. That's critical in the real file system because any input and output, any the application, any the instruction that would like to read the data from the file system go through this one. So if this one is complicated and need one more I/O, it will be huge amount of I/O that can degrade your performance. So as simple as possible for such a directory structure. So this is the simplest way to manage the free blocks. Anyway, such a big map or the bit vector require the extra space, but it's not huge, so you can manage in your directory structure. Also, if you wanna make the smart way of your free list, instead of the entire free block, you can manage the free list location of the free list, the contiguous block. For example, initially, so entire block, the file system are free, so you can manage only the 0 block. It's a starting point. Then allocate this one. If that one is used, then this will be, for example, 0, 1, 2. The 3 will be initial point. Sometimes in the middle of processing, delete and insert, delete and insert, you may have the, for example, 3 and this is a 10. So you can manage 3 and 10 only starting point you can manage in your files, the free list file system. Okay, that is the linked free space list. Also, there are different ways to increase the performance of that. So, for example, you can also store the address of the free block, okay, to find it. Anyway, so I think it's almost the same idea. You don't know how many blocks are available until you visit this one is the linked list allocation. the free link the free list management. So you need to manage how many blocks are the available. You can count such a, you can keep such information. Okay. I don't understand the test. I think that in this case, the linked list, make the group of this free block, okay? Make the free block and pass the address of the next free block. That is the group to make the group of the free list in the free block management. Also, you can manage the map of your space like this one. Okay, instead of the simple, the free list, you can manage the map. That is called the ZFS. ZFS is it manages the meta slide. So that is the meta your device information about the which block is occupied, which block is available, something like that. How can we increase the performance to manage such a free list? Instead of the keeping the free list in the file system that require the I/O, why don't we? When we start up your operating system with the file system, we actually load this data into memory. Okay. Sometimes if your hard disk drive itself has the memory cache area, you can load this information to the cache area in your file, the hard disk drive. Otherwise, you can even load this data into the main memory. Then the operating system should know instead of accessing the disk drive, so you can get the free list such a block information from the memory. So it can be called the buffer cache. Then the problem is when you write the data, so because this information is in the memory cache, so what if the file is deleted, removed, or inserted, this information is changed. At that time, if you allow this information should synchronize this one, it's a synchronous approach, otherwise it's asynchronous. Definitely asynchronous is more popular because the synchronous approach is required. It should be synchronized every time it's a changes. Then how can we keep the data with asynchronous? At the time we can use the log, the stayable, the area for the logging such an information. We will see such a logging approach later. Page cache will be discussed more in the memory management. Then I'm going to skip this part. Okay. Sometimes as I said, your hard disk drive may have the cache area, or so you can have the generator in the main memory or the virtual cache. So you can use such a cache area to increase the performance of the I/O. So this slide shows how to use such a page cache. So buffer cache is in the hard disk drive, and then that can be cached in the memory space as a page cache. Page cache will be discussed more in the memory management. It's a basic unit of the memory, the management. You probably heard about page in and out, okay, number of pages, okay, so that will be discussed in the memory management. Sometimes we can use just the buffer cache as a unified buffer cache, so any file system can use such a cache area. Then recovery. What if? So sometimes we can use the cache information memory area, okay, and with asynchronous, which means the data block and the directory information, it will be changed in the memory but it's not applied to the hard disk drive. Synchronous approach, it doesn't matter because it's a synchronized. So even though the hard disk drive is flashing or the power down, so we may not lose such information. What if the asynchronous case, but it's a changed but not applied to the hard disk drive? At that time, we need the recovery. Okay. What is a recovery? Anyway, we need to have certain information like a backup. If you have the backup data, you can restore such a backup data to the file system, then you can recover entire data. What is this one? The memory information, which is changed but not applied to this one. At that time, we can use. Anyway, there is no way to recover the data, change data in the memory. We may lose this information. However, we need to recover using log data or journaling data. Log data will be stored, not cached, it's in the hard disk drive. It's a stable device, like the hard disk drive or other based on a hard disk drive. So log data will be used for recover. This one is called the instance recovery. How can we do that? Whenever this data is changed, we will store not changed data, action or command. Action or command or the instruction that make this information is changed. Okay, for example, remove the file A dot full file from the file system. Okay, then directory structure is changed and the free list will be changed. Then in this log file, just journaling for what? The command action. Okay, not real data, before data or after data. So only the command. Once this one is clashed, it's not applied to the real file system, we will use such a log information. Then we do such a command. Okay, remove the file, then will be performed here. Then we will restore, recover the data applied to the memory cache, but not of this drive. That is the log structure. It's used for the many of the system, which is based on the transaction. This is called write ahead log. Write ahead log is used for database system. Also, it's a big data system uses such a write ahead log. It can be also used for the recovery of the cache in the file system. Another the others are NFS. Before I move to this one, let's go back to your project once again. So you are going to implement the file system PFM, port over file system. Okay. Let's say this is your file system where this file system is created in your operating system. In your operating system, you are using the, for example, NTFS. On top of, so for example, this is a C temp. Under the temp, you can create this file system. Name is a PFS dot. The first one is 1. Okay, PFS dot 1. Okay. So, how can you create? So first, you need to program for your photo file system command. Like let's say that is a PFS. So when you run your program PFS, then you need to implement such a command. for example, the first time open the PFS file. So let's say the ABC file system or the PFS file system. If you open this one, if there exists such a file, you can use. Otherwise, you need to create it. So how can you create this one? So first is a blank, the file, right? Then you need to format. Format means, it's not the very special. Format means in your program, you should keep the data structure of this one. First, 1K will be used for directory structure. The other 9K will be used for the data file. And then at the time, data block, at the time the block size, right? Specify the block size. So this block is a 256 byte. Okay. So block size is a 256 byte, which means how many blocks can you create in this? So for the directory, so it will have the 4 blocks. Okay. And this one, data block, how many? So 36 blocks you can have. Right? So using this information, you need to manage you should, in your PFS program, you need to have such a file system structure. What is? File FPS, file FCS, control FCD, file control block. So instead of managing all the information of the file in here, so you need to have the file length and the location or some required information, size. So you can create the FCD, data structure, in your program also. And also free list. So when you design the directory structure, so you need to keep such a free list, something like that. That we have discussed so far. And what kind of the scheme you use is your job to decide. Contiguous allocation or index allocation, linked list allocation, you can do that. Once that is done, that is the main part. Then you can implement the command like a put. Put means in the file system, so NTF file system, you have the TEMP, the A.put file. So in your command, so you can, this is a PFS command. You better use the command line interface, the PFS proper, like that. Put A.put file. If you run this one, then read this file. Then first check your directory structure, whether first you need to check whether there exists A.put file in your file system. If there exists, you can return error. Otherwise, you need to insert this one into the FCD. Okay? Then check what? Your free list structure. So using the size of the disk file, you can get the attribute of the disk file in your program, and you can check the file size. So file size is also there's one more. The limitation, the file length should be less than 20 bytes. So you need to check. So such a thing, because most of your operating system allow the bigger size of file, but this one is a very small, tiny file system. It limits the 20 bytes. Okay. Then after you realize the size of the file, for example, this is the 10 byte file. Then one block is enough, right? So you need to find one free block. Then, so for example, that one is this one. You need to just copy this file in this file. The location is offset is 24 probably, because this is a 0. The 1K, the 1023, and this one is what is the 2 to the power of 10? Right? 1024. So this will be probably 1024. Still the offset. Okay? Then copy as it is. So yes.
But the file size is bigger than 10,
Bigger than what?
bigger than 10K.
I think such a problem, I cannot give all the assumption, all the limitation. Okay? intelligently guess such a limitation. So probably I'm not going to ask. So the bigger than 10K size, the file, okay? Reasonable assumption you can guess, okay?
But in this case, what should we do? Create the other file system FSP again? Or
Two ways. You can create as many as possible. Like if you want to copy test the 1 GB size file, do you want to do that?
I guess because that's will.
So do not try to such an extreme case first. Okay? First try to solve the requirement first. Then, in case something problem like I did everything, so I try to copy 1 GB. Then at that time, think about what can be the solution. Okay? So this is just a minimum requirement. So then the other, it can be reasonable assumption or intelligent guess. Okay? And then, so you can, also even each block can be spanned or unspanned. So unspanned means even though you have the 10 byte, you will occupy entire block. Otherwise, you can share the other internal. If you want to reduce the internal the fragmentation, you can share this block with the other. That will be more complex. Okay, so you can select any approach, but I recommend unspan. Then the gap command, when you read the data, definitely you need to access the directory structure. So because how many users can use this one? Only one user is a portable, the personal file system. So you don't have to manage the system-wide, the process system-wide open file list or the per process file list. Only one user, one process can access this one. You can just have the open file list, the file list in your system. You don't have to manage the open file list per system, per user, just the file system at the file list. So from the file list, if there is no file, return error. Otherwise, you can copy this one to the file system. Okay. In case there is the file, it's the problem of you can either discard the command or you can override the file. And what else? Delete the file. When you delete the file, you don't have to delete this one, right? That's the user, most of the file system do not delete the data actually when they delete the file. Instead, you delete the information from directory structure. That's it. That will be simple. dir command, you can just list up directory. You don't have to travel all the block. Okay? It's just nothing but data. Okay, binary data. So you can just return this one. Even though you have the text file or the image file, whatever the file format is, doesn't matter. Okay, when you copy this one to this one, it's copy bit by bit, the byte by byte, as it is. Okay, and if we want to add the command, so that's another thing. Okay, because the other the general command. So I put the put R is the command. So you need to manage in your FCV. Another part will be command. Okay, add the information about this one. And here PFS is the end of your file system. Quit is the exit your PFS command. If we want to implement more command, in addition, if in case you successfully implement this one, definitely I can give the extra point if you implement more command of this. But in case you complete this one, so I gave the some limitation, minimum the limitation, like the file name size 20 byte, and each file system allocate the 10K, 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 okay, and also block size is 456. Otherwise, you can manage. You can assume any assumption. Okay. Question. programming language, it can be anything as long as it's run